Okay, students, so the first question is asking us to calculate the total capacitance of the circuit. Let us first of all take the data that we are having. What are we having is 1500 microfarad, and we are also having the voltage. We are having the PD of the circuit, which is 12 volts. So to calculate C total here, no need to come and do series and parallel connection here. No, you can calculate it directly from the formula C equals to Q all over V. So we have 1500 microfarad divided by 12 volts. By applying the numerical application there, we have 1500 divided by 12 will give us 125 microfarad. Remember, microfarad due to this microcoulombs. So that's it. Now let us go to the B part of the equation. The B part of the equation, the Roman 2, this one is Roman 1. The Roman 2 of the equation is asking us to calculate the value of X. Yeah, to calculate the value of the capacitance X. Now, since I already know the total capacitance in the circuit, let me come and calculate it algebraically. Algebraically, total capacitance will be what? These two are in series, then the equivalent here is in parallel with this one. So we all know that what? We all know that series connection of capacitors is exactly as parallel connection of resistors, and parallel connection of capacitors is exactly equals to series connection of resistors. So here I will have, since these two are in series, I will apply the parallel formula, which is 20 product all over sum. Then plus because they become non-parallel, I apply now the series formula plus X. So should be equals to how many? DC total is how many? 125 microfarad. Calculation here, you have here it will give you directly 15 plus X equals to 125. Don't forget all those things in microfarad. So my X is equals to 125 minus 15. 125 minus 15, which is 110. Don't forget to put your microfarad at the end. Yeah, so that is it. As simple as that, you come up with the value of X, 110 microfarad. Okay, Roman 3 is asking us to calculate the potential difference across the 60 ohm, the 60 microfarad capacitor. So Roman 3, they ask to calculate V across the 60 microfarad. Okay, where is the 60 microfarad? This is the 60 microfarad. We all agree that the PD across the point AB is exactly equal to the PD of the battery, which is 12 volts, since the two are in parallel. So this point here are the same here. Okay, it means when I reach here, I have my 12 volts. Since these two are in series, therefore they should have different voltage. This one should be V60 microfarad. This one should be V20 microfarad. And they are having different voltage, and they should share the voltage. They should share the 12 volts coming from here. So the PD across AB is being shared between 20 microfarad and 60 microfarad. So applying potential divider there directly, I know that V, which is 12 volts, is being shared in the ratio. Since they are in series, it's like parallel connection. The ratio 1 over 20 microfarad is to 1 over 60 microfarads. So making my V across 60 microfarad to be simply equals to, I told you that anytime you are adding 1 over a value, you start, rather than starting with 60 microfarad, I will start directly with 20 microfarad divided by 20 microfarad plus 60 microfarad times the voltage being shared. The voltage being shared is how many? 12 volts. Is the voltage across AB. So 12 volts. That is it. Without wasting time, you see that after simplification, I will have 20 out of 80 microfarad times 12 volts. So the V equals 60 microfarad kilovolt. You come up with kilovolt. So that is it. So the first thing you should first of all know that the PET across AB is the same as the PET of the battery, which is 12 volts, since they are in parallel. And this PET is shared between these two since they are in series, and the PET is exactly equal to the PET across X here. But here is being shared. This point A, this is the point again, this B here, this is it again. So it means that the PET across AB here is the same here, which is the same here, which is 12 volts. So that is it for Roman theory. So we are having 3 volts. Now let us go to Roman 4. Roman 4, let's say the B part of the equation. We are writing on the B part of the equation. And the last part, the supply is disconnected to the 150 kiloohms resistor. Calculate the time taken for the potential difference between A and B. The potential difference between A and B to fall to 6 volts. So we want the time taking. We are looking for the time taken for V to drop to 6 volts. The potential between A and B. It means that what? It means that when I will open the circuit here, the battery is no more supplying the resistor, the capacitors. So it means that we are not having a charging circuit again, we are having a discharging circuit. So these capacitors, the total capacitance across AB is discharging across the resistor 150 kiloohms. And we all know that from your formula booklet, the voltage for the discharge process, the voltage at the time T is equal to the initial voltage. The voltage at time T across AB is equal to the initial voltage V0 E exponential of negative T all over R RC. It's inside the formula booklet. So the voltage across AB for a discharge process is equal to V initial. V initial here is what? Our V initial here is simply 12 volts. And the initial amount stored. E exponential of T RC. Now we are looking for T. We are looking for T when VAB T equals to 6 volts. That simply means that I will come here, I will simply replace my VABT by 6, V0 12, exponential of negative TR RC. And all that one, this is C total. And all that C total that we calculated before, our C total was 125 microfarads. C total that we calculated is 125 microfarad, and R is this value 150 kilo ohms. So that is it. So here it is simple, it's just difficult. I should make T the subject. I will bring this one here. I will have 6 all over 12 equals to E to the negative T all over R RC. Then to move this E, I will apply link on both sides. 6 all over 12 equals to, when I will apply link, the link will go, I will stay with negative T all over R C. This implies T is equal to negative. When I will interchange this 6 up, down, negative will go. I will simply have RC total link 12 all over 6. RC total link 12 all over 6, which is the same as RC total link 12 all over 6 is what? 2. So that is the value. So after numerical application, by replacing R by 150 kilo ohms, C total by 125 microfarad. Microfarad, remember, microfarad is 10 to the negative 6. 150 kilo ohms 10 to the 3. So you have that your time will be simply equal to